Welcome to Scholars Academy. Today, we are breaking down the steps to master quadratic equations. A quadratic equation is defined as a degree 2 polynomial. This is the standard form, ax squared plus bx plus c equals 0. Crucially, the coefficient a cannot be 0. If it disappears, the equation is no longer quadratic. To solve a baseline problem, we start by splitting the middle term. Here, the negative 6x is broken down into negative 7x plus 1x. This grouping creates two factors, x plus 1 and x minus 7. Using the zero product rule, we know that at least one of these factors must equal 0, giving us our final roots of negative 1 or 7. Factorization is your fastest tool for equations with obvious integer pairings, but more complex numbers require a universal method. For equations that resist factoring, use the Sridharacharya formula. This quadratic formula provides a foolproof way to solve any quadratic equation, even when you need precise decimal answers. Map your coefficients from the standard form. Here, a equals 1, b is negative 3, and c is 2. Write the formula first to secure method marks. During substitution, carefully track negative signs, like this double negative on the 3, to avoid calculation errors. The quadratic formula serves as your ultimate failsafe, providing guaranteed mathematical resolution when intuition falls short. Predict an equation's behavior by looking at the expression underneath the square root, called the discriminant, or d. D dictates three outcomes. If positive, roots are real and distinct. If 0, roots are real and equal. If negative, roots are imaginary. Let's use the equal roots rule for an active recall exercise. Pause and try to solve for p. Since roots are equal, we set the discriminant to 0. This secondary equation, p squared minus 16 equals 0, reveals p is 4 or negative 4. Analyzing these parameters often yields the necessary insights without requiring the execution of the entire formula. Word problems require translating physical quantities into variables. Here, a 60-minute flight delay forces a pilot to increase speed by 300 kilometers per hour to cover an 1,800-kilometer trip. We establish the usual speed as x. Using the relationship of distance over speed, our baseline time is 1,800 over x. We represent the 1-hour delay by subtracting the new, faster time from the original time. Precise ordering reflects the difference. Cross-multiply to clear denominators. Consolidating terms leads to a standard quadratic equation, x squared plus 300x minus 540,000 equals 0. Remember to account for physical constraints. Mathematically valid roots, like negative numbers, must be discarded if they violate real-world logic, as an airplane cannot travel at a negative speed. This cheat sheet contains your core exam essentials, the standard form, the quadratic formula, and the 3 conditions of the discriminant. Take a moment to save this for your preparation. Mastering quadratic equations transforms abstract rules into a concrete language capable of decoding real-world logistics. Keep practicing, and we'll see you in the next lesson.